client, and we already saw that that does not really work that well. So what you have to do is you have to use a concept known as remote procedural calls. Basically, they're just custom events meant for multiplayer in Blueprint. So type in custom event and we'll call this one set some float. Some float is the variable name, so we just made a setup for it. Under this replicates tab, set this to run on server. Now what this is going to do is this is going to ensure that this runs on the server. So if you call this from an owning client, now we will get to the problem with it. And if we run it from an owning client, we are going to be able to call this on the server. So reliable basically means you want it to run in order. So let's say you ran 2 RPCs. So it's going to run in the same order if it's reliable. If it's not reliable, the order may change. Since it's networked, it's not instantaneous. So stuff like that can happen. So now I'll just make this reliable. I'll just go ahead and print a string and I'll call this one server RPC. So now what we can do is we can go ahead and we'll not do this set with notify. We can go ahead and instead of that, we can call our set some float. And let's see if we get anything printed. Now something weird happens. As you can see, we are not able to actually call this RPC. If I were to actually play this and if I open up the output log here, as you see it says warning unit driver process remote function, no owning connection for actor BPA C1. This is basically the display name of the actor. Function some float, set some float will not be processed. What has basically happened here is that Unreal basically does not know which client actually owns this actor. Now this actor isn't owned by anyone. And if you were to notice this RPC call, it says reliable replicated to server if owning client. Now this if owning client section which is there, that is what is causing our server RPC to fail. Now let's do a similar drill but inside a character. So if I were to just create an RPC here, so I'll just go ahead and create a custom event, and I'll just call this one sv underscore test, something like that, and make this one a server RPC, reliable. Go ahead and we'll just print out a string and we can say RPC called from character. Now we want to be able to call this from the client instead of begin play, since we are in the character anyway, so we can use a more elegant solution, maybe on a key press, so maybe K on the keyboard because we don't have any other thing, so K on the keyboard. So find it over there. So there is K. So when we press it, this will obviously run on the client which presses the key. We can call sv test. So go ahead and play this. And if I go ahead and press K, it works on the server. And if I were to press K on the client, it works on the server too. I mean, obviously it's a server RPC, so the function will run on the server. But the point is our RPC worked and our client was able to make the server RPC. Now what if we wanted to be able to call this? So from a client. So for this, you'll basically need to have an owner for this. The way you do it is through the spawn actor function. So if you've just placed it in the level like that, you will have to use the set owner method, which again, I mean, if you were to place something in the level, it's pretty obvious you wouldn't have an owner for it. But let's just see an example where we use the owner. So what we can do is, okay, we already have a spawn actor function. And for the owner here, this is something which I did a bit later. So for the owner here, go ahead and plug in self. So spawn an actor doesn't matter. The location and stuff doesn't matter. We aren't worried about the actual actor itself. We are worried about the RPC. So make owner self. And now what I want you guys to do is run this only on the client. So let's say, for example, we'll again do it on key press. So then that's going to be easy for us to manage. So we can manually call it. So on key press, what we can do, and we want to spawn this on the server obviously. We don't want to spawn this on the client because it is replicated, remember. So you have to spawn it on the server itself. Even spawning cannot be on the client. So make sure you spawn it on the server. So is server. Only if it is the server, we are going to spawn it. And obviously this will run multiple times because for each player which will be spawned, this will run. So there's no way for us to actually ensure that it happens only once, but nothing to worry. So we can just grab a reference to this. And we'll need to make this replicated if we want access to it from the client. So we'll go ahead and promote this to a variable. And we'll call this one obj for example. And make this replicated so that we can access it from the client. And now when we press the K key, we can just check if it is valid. I mean it will be, but just for a safety check. If it is valid, we can go ahead and call our RPC. I don't know what we called it. So we called it set some float. So we called it set some float. Go ahead and run this. Now if I were to press play and if I press K on the keyboard, as you see, we get server RPC printed. So if I were to check this, we have server RPC over here. And let's just test it on the client as well. So go ahead and press K. As you can see, server RPC is getting printed. So we are able to call it on the client. Basically, the ownership is important. Generally, it's a good thing actually that you wouldn't really require to call any RPCs from actors like this. Generally, you would have RPCs in your character, game mode, game state, stuff like that. Not in the game mode. Game mode, everything is going to run on the server. But for the most commonly used classes, networking is already set up for you. And in case you wanted to use it for an actor like this, I've shown you guys how to do it. So this is how you do it. Make sure you just set the owner. So let's say I don't actually set the owner. And if I go ahead and press play, this will still work actually. So if I press K, this is going to work. But if I do it on the client, it's not going to work. So that's one thing to note. From the client, the reason this won't work is because now that we do this, so let me just set the owner. When I set the owner over here, now when I press play, I have two characters. So one is on the server and the other one is on the client. And for both of these characters, the begin play is going to run. So this is going to run both for the server as well as the client. So for the first version, everything is going to run fine. But when this begin play occurs on the client's version of the character, even this character will have a begin play on both the server and the client, because since this is networked, this character will be spawned both on the server and the client. So when the when the begin play is called on the server for this one, that is when the owner property starts mattering to us. Over here, if we don't set self, in which case it will refer to this particular character in the game, our logic is not going to work. So that was pretty elaborate in my opinion. This is probably something which you wouldn't even require that much, but this is basically how you do RPC calls. Now there's one more type of RPC which I want to hint upon, and that is multicast. What if now that you're on the server, what if you wanted to print this for all the players? In which case it's really simple. Type in custom event and we'll just call this one MC underscore print. I mean, we actually didn't set the float here, which is kind of ironic, but we'll just do SV underscore print. So SV print. So we'll print this and we'll just duplicate this over here and make this a multicast RPC. Now, I generally don't prefer making these reliable. Generally, you would use multicast for things such as particle effects. So you wouldn't really need reliable, but anyways, I'll just do it for this example. And we'll call this one multicast. So we'll just call MC print. And remember, multicast RPCs have to be called on the server. If they are not called on the server, it will only run on that client. So it's not going to run on all the others. So if I were to press play as you can see, we get multicast RPC. So this is basically how we would go about doing this. Now this worked on the server's instance, obviously because we spawned it over here. Otherwise it wouldn't work. So if I were to just go ahead and press play, you would see it works. And if we had more players, it's going to work again. If I had 3 players, it's going to print it multiple times. So it's going to print it on the server, client 1 and client 2. So we have server RPC, multicast RPC, and stuff works like that. So this is basically how you would go about calling RPCs. So you have SV print, which is routed to the server, and we can actually test that out rather than doing it on begin play. That is kind of an incorrect way. Obviously I showed you guys the right way to do it. So this is some sort of logic which you would never use. So we'll just ignore all of this. Go ahead and press play. If I press K on the keyboard, you see we are calling the RPC. If I press K on the client, it works as well. If I press K on the other client, it works as well. And all of the players can see the printed string. Now you can also have the logic the other way around. So let's say you are the server, and then let's say, for example, I'm just taking an example here. Let's say when the game starts, you wanted to show a countdown, and the widget obviously will be spawned on the individual clients because obviously it's a widget, so it has to be spawned on the particular client's computer. So for that you will again use a client RPC. So I'll just do it over here. So let's say when I press the K key, we'll test this on the server itself. Client RPCs can only be run from that owning client or the server. If you run a client RPC from another client, it's not really going to work. So in order to do that, we'll just create an RPC. So we'll make this one CL_test and make this run on owning client. And what I can do now is I can go ahead and print a string and let this just be there. So if I do CL_test and if I were to press play, if I actually press K here, RPC called from character runs on the server. Over here as well, this runs on the client, and over here as well, this runs on the client. So this is basically how you do it. It'll just run on the client. But what if you wanted to run this from the server? So if you do this through a server RPC, it is going to be routed through the server. So I'll just do that and show you guys. So what we'll just do is we'll just DIY it ourselves. So we can say SV test, and this will run on the server. We can have another print string and we'll call this one SV for server. And over here, instead of that, we'll call the server RPC. And now what we can do is once this is printed, we can go ahead and call the client RPC. So CL test. Now if you were to notice, if I go ahead and press play, if I press K, as you can see, now both are called on the server. So the server RPC worked and the client RPC worked. But if I do this on a client, as you can see, the server printed SV and the server again called a function on this client. So this is basically how you would go about using client RPCs. So for any multiplayer logic, this is exactly how you would go about doing this. In C++, this logic is pretty straightforward. There are just a few additional steps for rep notify and replicating variables. But other than that, even the C++ part is pretty straightforward. So generally you would use Blueprint itself for core multiplayer logic unless it's something fundamental to your game and you want it to work properly. Like let's say you had like a firing mechanic or something and you don't want any sort of performance issues or any overheads, then you would use C++. Otherwise you'd really just use Blueprint for most of the things because it makes things so simple. As you can see, you don't have to do stuff like opening ports and stuff. So all of that is handled by Unreal. And now let's go ahead and see how to run RPCs in C++. Now I've gone ahead and opened up Visual Studio Now we'll just ignore the plugins part right now and we'll head into our source folder, beginner course, public, and we'll head into, first of all, we'll head into a character. Now what I want you guys to do here is, first of all, before you actually use any networking feature, just make sure you include net/unrealnetwork.h. Make sure you include this header. If you do not include this header, you'll get all sorts of weird errors. So make sure you do that. Now, first things first, let's talk about variable replication. So if you want a variable to be replicated, you basically have to make it a U property, first things first. And this one will give the specifier blueprint read write as usual to make things simple for us. And one more thing which you have to give is you have to give the specifier replicated. And we'll make this, let's say, a float replicated CPP variable maybe. Now one more thing which you have to do, this is additional, this is not something you have to do in blueprint, but one thing you have to do for the replication logic to work is you have to actually write one function in the CPP file of our character. We'll go ahead and do that, and then we should be able to make this work directly. So I've gone ahead and opened up the documentation. So this is the function which we actually need. So we can go ahead and copy this and paste it inside our character.cpp file. So I've opened that up and I've just written a comment called replicating variables. Go ahead and paste it, and we can go ahead and have a definition for it. So over here, this is going to be a cpp underscore character. Just put your class name followed by the scope resolution operator. Then you can go ahead and just move everything to one line to keep things clean. And over here, you'd want to run this macro called doRepLifetime. And this takes in two parameters. One is the class, which is going to be our current class, and the variable name. The variable name is going to be this, or it's going to be replicated CPP variable. Now I'm recording this a bit later, but one thing that I forgot to mention is make sure you call super of this function. Otherwise, you'll get weird classes when you use the weird artifacts when you use the derived classes. And for the parameter, you can just pass this in. So make sure you just do that. Otherwise, your movement variables and stuff will not be replicated if you use your BP character. So that's one thing to note. And now if I were to go ahead and run a debugger, we should be able to do it. Just make sure you close the editor and then run a debugger. So as you can see, the build succeeded. And now we should be in theory able to use this variable as a normal replicated variable in Blueprint. So I'll just show you guys. Replicated variables are shown with those two balls on the top. So BP character is inherited from CPP character, so we should have it. So if I just type in CPP get replicated CPP variable, and as you can see, this variable is replicated. If I were to actually go ahead and check this variable over here, it says CPF net. This basically means it's replicated. So now this should work like a normal replicated variable. Now I'll show you guys how to handle RPCs as well. So RPCs are simple. I'll show you guys how to handle server and multicast RPCs. I won't really go over client RPCs. They work pretty much the same. So I'll go ahead and stop this now. And for RPCs in C++, you need to basically have a U function first of all. So create a U function, and you cannot make RPCs in C++ blueprint callable. However, you can wrap them inside another function and then make them blueprint callable or whatever. So what I'm going to do is I'm going to put the specifier server, and one more thing, I'm going to make this either reliable or unreliable. So this is where you specify it. So reliable, or you can make it unreliable. Now I can go ahead and actually write something here. So let's say void test server RPC underscore CPP. just to indicate that this is in C++. Now what you need to do is you need to define it over there, but also rather than defining this, you're supposed to define another function known as the implementation for this. So what we are going to do is we are going to just copy this over into the next line. This need not be a U function, and type in underscore implementation. Okay, just ignore the parentheses there. Implementation. And now what we can do is we can create a definition for this instead. So I've already done that. So I have the definition for this, and we can do something simple such as a print string. So ukismet system library print string, and we can go ahead and print in this is a server RPC from C++. Now this should in theory work, and if we want to call this RPC, what we would do is you can just go ahead and call this. We don't have to call the implementation, we have to call this in order for the implementation to get called on the server, or we could just do something else such as wrapping it in another function. So I'll show you guys both the approaches actually. So I'll just do it on begin play. So on begin play, what we'll do is we'll go ahead and we'll actually delete some of this code. So we'll delete this, and what we can do is over here we can go ahead and check. So if we are on the server in fact, or if we are not on the server, we are going to do it. So if is server, so I guess it's called G is server. I think it's a variable, not a method. So if this is not a server, we are going to call this RPC. Over here we'll call test server RPC underscore CPP, and this will work as expected. And we can go ahead and wrap this in a blueprint U function. So we'll create a U function, make this one blueprint callable, and from here what we can do is we can just type in void wrapper for CPP RPC, and this one we can just write it like any other function and the RPC will run. Now what you can do over here is you can go ahead and run this function inside of that. So we'll go ahead and call this, and since this is blueprint callable, we can go ahead and just call this from blueprint. Also realize that just because of the way the function call works, this is not going to run at all. No matter what you do, it is going to come outside the if. So if it comes inside the if, it's again not going to, the condition is again not going to be valid, so you're not going to run this function. So anyways, we'll just run it as is, and then we can go ahead and run a debugger. So now if I were to actually go ahead and wait for it, so once it loads in and I go ahead and press play, if I press play right now, you would notice that you get this is a server RPC from C++. So we got two server RPC calls, one from the client and one from the server. Now I'll also set up some logic so that we run this during gameplay. So under your BP character, what we can do is we can run the wrapper. So type in wrapper for CPP RPC. Now if I go ahead and press play and press K on the keyboard, as you can see, it runs on the server. And if I do it on the client, that works as well, totally as expected. Now one extra feature which I want to cover in C++ RPCs is the validation. So if I just type in a comma and type in with, okay, I have my caps lock on, with validation, now what I can do is I can write a function which returns a boolean, and instead of underscore implementation, if I type in underscore validate, you can make it so that this function will only run under a certain condition. This is especially useful for something like cheat detection. So if I were to just create a definition for it, And what I can do is, if this returns false, basically this client which is calling the RPC will get disconnected immediately. So I can just do return true for now, and this RPC is going to run. So if you had something like a health variable or something, and you do something like if health is, less than or equal to 100, and or maybe if you had any other condition. So let's say the health, you had a set health function, which is an RPC of course. So then you would check if it is less than or equal to 100, because you don't want the player to set the health to a value greater than 100. Stuff like this, but for now we'll just leave this to true. This function will run. Just to showcase, I'm just going to print string once again. So this, and we'll call this validate. And we'll not do this on begin play. So oops, print string. Go ahead and run a debugger. And before we do that, I'll actually just show you guys how to handle RPCs as well. I mean rep notify as well. So let's say I wanted to make this rep notify. I would use the replicated using flag. We'll do it after this actually. Now if I were to go ahead and press play, as you would see, the validate function was also called on the server. So the server is going to validate, and accordingly it is going to disconnect the client if the condition is not met. So that function, whatever we saw right there, that has to return true in order for the RPC call to take place successfully and for the client to continue stay connected. So this is basically validation. And now let's talk about rep notify. I am back inside the header file, and for rep notify, over here you can just go ahead and create a function. So what do we call this function? This need not be a U function, but you can make it as well. So we'll call this one on rep. It's just a convention to use on rep, but it need not be. On rep wrapper for CPP, let's say. For CPP. And this one will just be void. No need to return anything. You could return a value if you wish, but there's really nothing much you can do with it. Go ahead and write a function definition for it. Now again what we can do is we can go ahead and just print something. So we'll just copy this over, and rather than validate, we'll just print rep notify from C++. So now what we can do is, now we can feel free to come in here, and rather than typing in replicated, type replicated using equals and just pass in the function name. So you don't have to pass in anything else, and this is going to work as you would expect. One thing that you would want to do is, wherever you call this function, that will obviously be on the server, make sure you call this function as well separately. So where you set the variable, so we are setting this replicated CPP variable, so we'll do that. Make sure you call this as well. So if you're setting this in blueprint, make sure you make this function a U function and make it blueprint callable. So we'll do that actually. There's one issue with it in C++. This is how we would, this thing works in the same way as it works in blueprint. So we'll just do it on our RPC itself. Anyways, we are running the RPC. So in the implementation for it, we'll not have the print string. Rather, we will have our rep notify. The way you do that is, we'll modify the value of the variable. If you modify the value, automatically rep notify will be called. Equals, I'll just type rand mod 19. I just chose a random number over there. And what you want to do is, you would want to call this function only over here, and the rest will be handled for you. Now we can go ahead and run a debugger, and you would see that our rep notify will be called, and rep notify from C++ is going to be printed. It just works just like that. So wait for the editor to load in, and once we are inside the editor, if I go ahead and press play, as you can see, rep notify from C++, and it was called on the client as well. Since there are two versions of the character here, so one on the client and one on the server, both of them called it 2 times, so that's the reason we got 4 prints. And the same thing is going to work when we use the wrapper. So if I just type in K for example, you see the rep notify works. So we get the validate, rep notify as well as anything else that you would expect. So rep notify on the server and the client. And if you want to do the same in blueprint, so you can go ahead and set our replicated CPP variable to something. And you would notice something weird. First of all, I have to do it on the server. So we'll do it on a server RPC. So SV test, rather than doing CL test, we'll go ahead and set the value of this variable. And we can do SV test. Go ahead and close this. And if I were to press K, let's just wait for it. As you see, this rep notify is only called on the client. This is not actually called on the server. So in order for rep notify to work, again once you do this, you will have to type in on rep wrapper for CPP. So make sure you actually type that. So now if I were to go ahead and press K on the keyboard, you see it runs both on the server and the client. So there's just one extra step which you have to take in C++. That is if you have your replicated variable in C++. So that's about it for rep notify. I guess we have covered almost all aspects of replication. Multicast is something which I'll just talk about. So all the same parameters except over here you'd have net multicast. So don't mind the spelling, I mean the capitalization. So I have my caps lock on, net multicast, and this will work as expected. You can again have your reliable and validation and stuff like that. The rest of it will remain exactly the same. So you'll have your implementation and you can have your validate if required. But you wouldn't really have a validate for a multicast RPC. So I'll just go ahead and delete that. And this should work just as expected. So I'm not going to really show that. This is how you would basically set up a multicast RPC. And the documentation is there. We did the example for the server. There are no syntactical changes to this, so it should be totally okay. So we'll just delete that definition, and I guess then we are done with multiplayer, guys. Now that we are done with covering all aspects of game development in Unreal Engine, let's go ahead and actually take a look at how to install Unreal Engine from source. So the main part is actually done. Now we'll be doing a couple of things such as downloading the source, looking at how we can build it, as well as we'll be going ahead and changing the engine version on our existing project. So first of all, as I mentioned at the very start of the course, make sure you guys do get access to this repository here. As of this date, the release branch should have 5.1.0 and you should be able to download the zip file over here. So download the zip. First of all, especially when you're installing Unreal Source, just to avoid, the permission issues which you're going to get, make sure you head into your C drive, new folder, and just create a folder called Unreal Source or something. Need not be the C drive, just make sure you do it in your SSD if you have one. So in my case it's the C drive, so that's the reason I'm doing it. So I'll just go ahead and install it there. So go ahead and extract the files. Over here under C, I'll go ahead and browse the directory over there. So C Unreal Source. Go ahead, extract, and extract it under that directory and hit OK. Now we're just a few steps away in order to install Unreal Engine. So first of all, go ahead and run your setup batch file and try to run it as an administrator just to ensure it has all the permissions for everything. So run the setup batch file as an admin. So something like this should show up, and once it's completed, we'll head into the next step. After the setup batch file has completed running, you can go ahead and run the generate project files.bat. So this file is basically going to generate your Visual Studio solution. So let's go ahead and run that again. Try to run it as an administrator. Should work regardless, but if you do get any errors, just run it as an admin. So you should see something like this, and this should complete relatively quickly. At this point, you should be able to see your solution file. So go ahead and open it up. Once the solution is open and you see ready over here at the bottom left hand side, what you should do is you should go ahead and head into engine, and if it does ask you to install a few more components in Visual Studio, make sure you just go ahead and do that, just follow along. But in my case, I've already done that, so I'm going to go ahead, right click on UE5 and click build. Now once your build has succeeded, under your engine, binaries, Win64, you should find Unreal Editor.exe. So by default, the build configuration is set to development editor. If you don't see this, it means your build configuration was probably something else and it didn't get built. So anyways, let's go ahead and open it up and our editor should load up. If we do get any errors, we can go ahead and debug it now. So everything seems to be working fine. And it is going to compile some shaders. Once that's done, I'll be right back. Alright, so now what I want you guys to do is go ahead and copy your beginner course project, and now I'll show you guys how to change the engine version. So head into your beginner course uProject file, right click, switch Unreal Engine version, and now you should see source build at whatever. So basically I opened and closed the editor, that's it. So whatever we did there, opened Unreal Editor.exe, I just closed it immediately, and now I'm back to this location and you should see this. So if I hit OK, it is going to generate some Visual Studio project files, and unless something's horribly wrong, it should in theory work out of the box. So that's about it, and now you can go ahead and just build your solution once again, because there may be a few API changes which you might have to make. So those will be listed in the output log and as well as in the release notes and the documentation or whatnot. So head into your solution. Now we have switched the Unreal Engine version. So now we can go ahead and right click on our beginner course and click on build. So we get our first error here, and this is actually fairly common. So basically we have switched the Unreal Engine version and we have a plugin over here which is based on the older version of the engine. There are two ways to fix it. One, you can head into the marketplace and reinstall the plugin which is meant for 5.1, or I'll just show you guys the way to do it without using the marketplace. So in the marketplace it's really easy, you can just go ahead and update the plugin. But over here, if you really want to just use the same one, what you can do is you can head into your engine installation directory. So in my case it is C, Unreal Source, Unreal Engine Release, Engine, Plugins, Marketplace. It's not here because we haven't yet installed, so you'll find it there. So we'll go to our previous installation, program files, Unreal Engine. This is where I had it, UE5.0, Engine, Plugins, and you should find Marketplace. And the one we are interested in is low entry extended standard library. You don't need to copy it to the engine installation, although you could. What I'll do is I'll just take it to the plugins folder over here. So over here, and inside the uPlugin file, we'll do the same modifications. Over here, what we are going to do is under the engine version, we are going to type in 5.1.0. And now if we go ahead and try to build this once again, we shouldn't get that error, hopefully. So it will take a while, and if we do get any errors, we'll go ahead and change it or fix those. So we have a few errors here, and these are mostly the changes which came according to the documentation due to the platform SDK upgrades, but it's not really a problem. So because I don't think any of you guys, unless you guys work for a AAA studio or something, I don't think you'll be using this. And this is from the plugin, this is not something in the engine, so nothing to worry. So what you can do is we can simply just delete this code and just do return false. And even for the Xbox one, so we can just do the same thing. and I'll tell you guys which file this is. It's basically this file right here. So in the error list, you see platform PS4 whatever. So just head into that, just double click on that and you will reach there. And over here as well. So line 264. So I feel like this was it. So before changing it was in line 264. So now it's gone a bit up. Anyways, let's try building this once again. And as you can see, the build has indeed succeeded. But once the plugin actually comes for 5.1, what you can basically do is install 5.1 here, like in the Epic Games launcher, install the plugin from the marketplace, and then you can go ahead and copy that into the plugins folder in the engine level. So what you would do is you would have it over here. So C Unreal Source, Release, and Engine, Plugins. Over here you would create a new folder called Marketplace or something, and then you would like just copy it in. Anyways, we are not really worried about that right now. Now what we can do is, now that it's built successfully, we can go ahead and run a debugger, and we should be able to run this in 5.1. So I did show you guys multiple things. So the errors which you get will actually depend on what plugins you're using and how's your code base and what changes are made to the engine's API itself. So depending on that, you'll have to look at the output log and the error list and do something. And there are a few deprecation warnings as well. So if you just have a look. So I'm not really sure what this is, but this will probably be changed soon once the plugin is updated. But right now I'm not really worried since it's just a warning. So now I can go ahead and run a debugger. Alright, so our project has opened successfully and it is prompting us to change a few project settings in order to actually use virtual shadow maps and nanite. So that's not really an issue. We can head into the project settings, and over here under, it should in theory be here. So platforms. So let's just search for platforms. It'll be under any one of these. So platforms, Windows, and you can go ahead and enable shader model 6. And over here we can go ahead and I don't think we'll require shader model 5. So that should be about it. And now we can go ahead and restart the editor. Alright, so now I've restarted the editor and now we are using Unreal 5.1. So that's about it for installing the source and changing your engine version. Now there are a few more ways you can handle some of the things, such as the plugin part, but on the whole this is how you do it. And if you do want any more specific references, you always have the documentation which you can refer, and the release notes, and maybe the Unreal Slackers Discord server. So that's about it. Alright, so we're finally inside the last section of this course, and obviously it is about how to package your game. So it used to be very simple before, so you just go file, package project, but now you probably have to just do it through the project launcher, which I will show you guys. It's really simple. So head into tools, project launcher, and you can use this, but I'm going to be using a custom launch profile. So go ahead and create a custom profile, and I'll just walk you guys through each option. You can give a name to this profile. Let's say this is for testing. Let's say you're building this for testing, so you can name this profile testing. You can reuse this profile for the next time when you package the game as well. Packaging basically means you make your game, or you turn your game into an executable basically. Now project is going to be beginner course, of course, and build configuration. So debug and development will be used when you're actually, testing out your game and you're still not yet at a stage where you can send it to other people. So your print strings and stuff are gonna work. But under shipping, none of your print strings and stuff will work, but it will take a bit longer to build. And testing is somewhere in between debug development and shipping. So it's below shipping, but it's above development and debug basically. So you can select any one of these. I'll just select shipping. And here, these are settings we don't need to worry about. And about cooking the content, you can do either on the fly or by the book. Basically, what on the fly and by the book is going to differ in is basically if you do by the book, everything is going to be cooked beforehand basically. So if you're packaging your game for shipping, most of the times you will have by the book, and you would select Windows if you're developing a Windows game. Obviously, if you have anything else, let's say you're making an Android game, you would select Android and stuff like that. And under cook cultures, you'll find English somewhere here, so EN. It should be selected by default, so EN. And you can select your maps which you want to cook. So we are using all, so we'll just select all, but you can choose to cook only selected maps. But note that if you don't cook a certain map, you won't be able to open it in game. You're going to get errors. Your game will probably crash. So that's one thing to note. Now, release DLC patching settings. These are some things which I'll not go over. And under advanced settings as well. So you can go ahead and mess with these. So you can enable this if you want all the content to go in a single .pack file, stuff like that, and everything is pretty self-explanatory. Next, package and store locally. Then you can go ahead and give it a path. So generally I'd like to do it in the project location, saved, and I'd like to create a folder called staged builds. If you've used the project launcher in the older versions, you probably already know what this is. And is this build for distribution to the public? We have selected shipping, so I would assume it is. Of course, it's again your preference. Do you wish to archive? You can select yes or no, doesn't really matter. And deploy, we can select do not deploy because we aren't actually launching the game. So if we select do not deploy, basically you can launch it through the executable itself. So once that's done, you can head back and you can click on launch this profile. So now once everything has been completed, you can head into the directory over there. You should find a Windows folder and you should find your executable right there. So open it up and you should launch your game. So we will end up in this map right here. Again, you can change your project settings and you can change the default map. But anyways, our purpose here was to check if the game packages, and everything seems to be working. The physics simulation works and so on. So that's pretty much it. Okay guys, so this is going to be the last segment of the course, as you guys would know, and I hope you guys would have enjoyed the course till now, and congratulations if you have completed the course till here. And the further part is going to be 2 hours of me creating an entire game. So hopefully you guys will enjoy it. See you in the engine. Alright guys, so this is the last section of the course, and this is not actually going to be about, learning anything new. However, in this part, I will be live demonstrating without any cuts how to make an endless runner such as Temple Run or Subway Surfers or any other which you might have played. So we'll be taking the most simple approach, or at least as far as my knowledge is concerned. If you do have anything simpler, you can let me know in the comments. And hopefully within an hour, we'll be able to make the whole game with the menu, animations, and all that kind of good stuff. So let's get started. So let me actually have a stopwatch here so that we have track of our time. So I'll just create a game. It's going to be third person because we'll have the animation blueprint and stuff. But anyways, I don't think we'll be using that. Not to worry. We'll go with blank actually. C++, and we'll call this one endless runner. Create it. Now this will take a little bit of time. And I do have a couple of things being installed in the background, and I also have a list of plugins that I'll be using. So you guys will have a pretty good idea of what we'll actually do with plugins and stuff. Because in the course, I think I just went over these briefly, but I went in depth about how to actually create your own plugins and stuff. Anyways, so our project will be created soon, and this will compile. So until then, we can go ahead and open up our Epic Games launcher, head into library, and we can close this editor for now until we add everything. So what I'll do is I'll go ahead and search these one by one. So city, subway tunnel. So I have to create a separate project for this. Not gonna go over that right now. So we'll go construction volume. So volume 1 and volume 2. We'll go ahead and add this to endless runner. We'll add this to endless runner. I'll clear the cache later. It's just taking up storage. And we want LE extended. So LE extended. So we have already installed it to 5.0.3, so nothing to worry about there. So adventure character, whoops. So this will be the character which we'll be using, and it's going to be hella fun. We don't have time to actually model our own character. That's the reason we are doing this. So I'll just go over this real quick. So FX variety pack. Not sure if we will get the effect we need, but I'll just add it just in case. Okay, I need to download it yet, so not gonna do that now. So window dialog box. So I've already installed it. So these two. So we'll use these for obstacles and stuff. And lastly, we'll just have some trees. Maybe at the side we could have something. Stone pine forest. And go ahead and add it. Once everything is complete. Now, depending on your system, if you have a hard drive or something, this process is going to be a little bit slow. So this is under my Unreal projects, endless runner. So we'll be using the file explorer for this. And I'll just delete this later on. So now once the engine is loaded up, we can start making our game. And we'll go ahead and create a maps folder first. So right click, maps. We'll have only one. And all the obstacles will be spawned at runtime dynamically when you're playing the game. So we don't really care about having multiple maps, but we'll have two. So one is going to be your main menu, and the other one is going to be the actual map. So I'll go ahead and create the map, and I'll call this one game map. Alright, save that and go ahead and open the main menu. Head into project settings and just change that as well. So under your maps and modes, you should have open world. We'll change that to main menu. So editor startup map will be main menu, and it's going to be main menu again. So editor, we can start with our game map actually, but the game has to start from main menu. So just go ahead and click import. Doesn't really matter. Alright. Now over here we can start making a main menu. So right click, create a new folder, and we'll call this one content once again. And inside this we'll actually create stuff because the main content folder is a bit clogged up. So we'll call this one UI, and we can create a main menu. Right click, user interface, widget blueprint, create a user widget, and we'll call this one main menu or BP underscore main menu. And we'll suffix that with a WB to indicate it's a widget. And it's going to be just quick and dirty, so we'll add a canvas panel here. And at the center, we'll just have a start button and an exit button. So we'll add in a vertical box. So vertical box, and over here we can go ahead and make this center aligned first of all. center align position 0 with 0.5 for the alignment value. So this is going to make sure everything is centered. We can go ahead and increase the size a bit, even vertically, and we can go ahead and add in 2 buttons. So button 1 and Control D to duplicate. We'll make it so that it fills it, and we obviously want the play button to be bigger. We don't want our users to exit the game. Anyways, we'll add in the text here. So add in some text, and change the background color for both of these buttons. Make it almost black. Maybe not exactly black, but almost. So I like this shade of color. Now rename this to play, or rather start, we can try. Change the font maybe. So the font we'll use is going to be the light one. So 40 seems about right. Make this one 40 as well, and this one is going to be light, and this one is going to be exit. So we can add the functionality as well, because this is pretty simple. So on this button, we'll rename this to exit button, or it's really not required, I guess. So on click, and for this one as well, we are going to add an on click. This is the start button, so I'll just comment this out. And for this, we can go ahead and execute console command, and we can type in exit. Now our exit button should work. We can go ahead and test that. First of all, we haven't even created the widget. So under content, we'll go ahead and create a new folder and call this one blueprints. And we'll have 2 subfolders here. We'll call one as game and the another one as main menu, because we'll have different player controllers and stuff for the main menu and the actual game. So under main menu, right click, go ahead and head into blueprint class and create a player controller. And we'll call this one BP main menu player controller. So this is basically for, creating the widgets and stuff. We'll just use the player controller. Now under the event graph, we can just do it on begin play. So we'll create a custom event, create main menu, and create a widget. It's going to be BP main menu widget blueprint, and add this to the viewport. Now I don't think we really need the reference, but we'll just store a reference to it anyways. So main menu widget blueprint, we'll just have a reference to it. And from this, we can go ahead and add it to the viewport. Alright, and on begin play, we can create the widget. So create widget, or rather create main menu is the function name. So create main menu. And now if I compile, save it, go ahead and press play. As you can see, nothing happens because we haven't changed the game mode yet. So over here we'll create a new game mode. So go ahead, all classes, game mode. So we'll create a game mode base. So we'll call this one BP underscore main menu game mode. Now under your world settings, go ahead and change your game mode to BP main menu game mode. And over here the player controller can be our BP main menu player controller. And now if I go ahead and press play, we should get our buttons. Start won't do anything, but exit is going to work. Now let's actually head into our game map here. So maps, game map. We'll worry about the main menu a bit later. So we are in the game map. We can go ahead and add our sky. So sky atmosphere, skylight, and we can add in our directional light. We can also have a fog. So we can have exponential height fog, and we have everything set up. Now we could change the time of day as well. We'll make this one dynamic for now. So fully dynamic light, because I don't have any time to actually build this. So go ahead and rotate it to make it like a morning or evening scene. This should be about good. Not gonna spend too much time on it. Save it up. And over here under content, now we can start building the actual level. So I'll just go to my blueprints folder here. Under game, I'm going to create the game mode and stuff for this one as well. So type in game mode. So I'll create game mode, BP game mode. This one is just going to be called BP game mode because this is for the actual game itself. Under your world settings, go ahead and change that once again. So BP underscore game mode. We'll have a CPP game mode if we really require, but I'll try to stick with blueprint as much. Now let's check our time. So 10 minutes in. Now under your game mode, we'll also have a game state to count our score and stuff. So game state. So game state base BP underscore game state. So we have our game mode, oops, and we have our game state. And now we can also have our character and stuff. So we can create that. First of all, we can just right click, blueprint class, character, and we can type in BP character. Open it up, and we have some basic things already set up. For this mesh, we'll be using one of these which we bought under man. Under mesh full, we have all these various options. So we have 4 options. So we'll be using these 4. So these 4 will be the options for the players to choose from. That's how we'll do it. So we'll create a derived class for this for BP character. So under our characters, what we can do is I can type in character. I'll just move this here and go ahead and type in subclasses. So this is like your main character. So every character is going to be a BP character, but then we'll specifically make them choose a mesh. So go ahead and create a blueprint class, type in character, and over here we can make it of type BP character and call this one character 1. We can actually just name them. Maybe we'll call one Adam. Duplicate that, we'll call one John. I'm just giving generic names. We had 4, so we can call one Jason, and maybe we can call one Bill. I just chose random names. So open this up, and for the mesh we can go ahead and start replacing it. So head into the location where we had the mesh. So this is going to be our first character. We'll set up the animation blueprint a bit later. So it's a bit off, but not to worry, we can go ahead and adjust that. -90. And we can head into the other classes here. So under content, blueprint, game, character, subclasses, we can head into Bill. And this was called SK Manful 1. So we'll call this SK Manful 2. Over here we can select SK Manful 3. So SK Manful 3. And for this one we can have SK Manful 4. So SK Manful 4. So that's pretty much all set. So I'm not sure if I should just use the default one here. So Manful 1. Not sure if it will inherit the transforms, so I'll just try this. I'll compile this. So if I open the full blueprint editor, okay, it has inherited the transforms. That's a good thing. So we don't have to do everything once again. Alright, so we have our character set up. In our main menu, we can go ahead and add a character selection option. So head into content, our actual content folder. Under the main menu, we can have a button somewhere, and maybe over here we can type in change character. So I'll change the color of this. I'm not really worried about the visuals as of now, so I'll just go ahead and change this. Okay, I changed the color. So background color, I'll just make this dark again, and we can add in some text, and we'll call this one change character. Alright, make this a little bit wider so that it's visible for our player. So make this one 45 maybe, or 35. 35 seems good. We'll make that one light once again. Maybe we could make start a bit bolder. So let start be regular, because we want our players to deliberately click start. Alright, so once you click on the change character menu, it should just give us a list, and we will create the widget for that. Now we'll also need a game instance class. Head into blueprints, and game instance is general, so we'll create one here. So game instance, go ahead and call this one main GI or something, and under the project settings we can go ahead and change it. So game instance, change that to main GI, and over here we can have a variable for selected character, and we can change that actually. We can change that to be of type BP character class. So we have BP character, we should see it somewhere here, BP character class reference. So this is going to be the character which we have actually selected, or we could have it in a struct. We'll think about that a bit later. Now once we have that, we can go ahead and start making the actual obstacles and stuff. So one thing to note is that we want to make this modular in a way. We want to be able to spawn them one after the other. Let's just go ahead and do that. So when the game starts, we want to have a bunch of obstacles, and then we'll look at what to do. We'll work on the obstacles after we work on the animations actually. So we'll head into the skeletal mesh. We have certain animations. So content, blueprint, we'll head into character, and we'll create the animation blueprint right here. So animation blueprint, and we'll go ahead and select our UE4 mannequin skeleton. This is the one which comes with the pack actually. So create, and we'll call this one character animBP. Open it up, and inside this we have a bunch of things. So we'll create a state machine, doesn't really matter. Now we can go ahead and have an idle. So we'll have idle, and we'll create a blend space for this. So right click, go ahead into animation. So basically this is for transitioning between your idle and walk animations. Blend space, and we'll call this one walk run. Okay. Over here we'll have few things in the horizontal and the vertical axis. Horizontal axis is going to be the direction, and the vertical axis is going to be the speed. So we'll go between 0 and 600, but we'll see if we can do something else a bit later on. Now open this, and we can have our third person walk halfway over here. We can have our third person run full way, and we can have our third person idle at 0. So we transition between these, something like this. For the direction, we'll have a negative 180 and positive 180, obviously. So this will be like your angle from your forward direction. That's basically what this is. Now we can change the animation blueprint after we actually set it up first. So for the idle, we have our idle animation playing, and we should already have this working. And we can have this as a new state. So walk run. We will set up the conditions, not to worry. Whoops, go ahead and do that. So on begin play, we can go ahead and get the pawn owner and cast to BP character. And we can make this a pure cast because this will succeed. Or if it doesn't, we can go ahead and poll it. And once we get access to our character, what we can do is we can get access to the speed. So get velocity. And we want the vector length. Right now we have a vector, and we want the magnitude of this vector. And we can promote that to variable, and obviously the magnitude of the velocity is nothing but speed. So speed. And we can also have direction. So get actor rotation. We'll set it up a bit later actually. Okay, so under the update animation, What we can do is we'll need this on every frame, so we'll use a reference instead. So promote this to a variable and call this one character ref. We'll be using this multiple times. So we can drag this over there. So this will be our speed, and also what we can do is we can also get the direction. So we can use this function known as calculate direction, and that is what will set the direction to be, set direction. So we'll create a new variable called direction. It's going to be a float once again, and we are going to set the direction to be equal to whatever this is. For the velocity, we can just grab in our get velocity here, and base rotation is going to be the actor's rotation itself. So get actor rotation, and we can plug this into the velocity as well. Now what we are basically doing is we are calculating the direction so that we actually input the value correctly in our blend space. Basically, we are not using this value anywhere else. Oh, here we can plug in our direction and speed. So direction and speed. So these were our vertical and horizontal axis values in our blend space. We can also have jump, which we will do. We don't have a state transition. So if speed is greater than, let's say, 10, we can go ahead and transition. And over here as well, if the speed is less than 10, we can transition. So rather speed. So speed is less than or equal to 10. We can go ahead and transition into this state. So now we shouldn't have any of those warnings. Alright, now if I actually create something here, so I'll just create a player start, so we'll know where to start. So player start, and I'll just go ahead and box out a simple level. So shapes, so I'll have a cube, and I'll just make this really big. So this is just for testing purposes, and for the default pawn class, I'm going to select BP character. And let's set up the animation blueprint over here. If we go ahead and select our character anim BP, in theory everything should work fine. So our camera is a bit off, that's nothing to worry about. So under our BP character, we need to set up a camera. So add a component, and this will be of type camera. Go ahead and add it. We can adjust the view, that's nothing to worry about. And if I go ahead and press play, we have our camera here. So we can make that a little bit further back, maybe tilt it down a bit, and I hope this looks good. Okay, so this looks good. So we have assist none in our character animation blueprint. So that's only in the first frame which is happening basically. So we can convert this to a validated get. That's a simple fix. You can go ahead and turn that into a validated get. Go ahead and press play. And now we shouldn't get those errors. You can set up our movement logic real quick here. So the character is always going to be moving. And I think we might have to change the animation blueprint here, because we always want him to be running, because we don't want him to stop. So we'll always have running actually. So sorry for that, but anyways, there's something we can do. So he'll always be running. So this is how he'll always be. And we can also have, a copy of this. So we'll just copy this over, and we can type in run fast. We can make this go at a higher speed. So there should be a speed multiplier somewhere here. So playback speed is what it's called, I assume. So playback speed. So nothing under the details. we'll look into that. So there's actually an option called playback speed. So we are going to increase the speed and make it so that it's actually as if he's